What is up, bros? Care to math? You know I do. That's why I am back today with another video lecture. Today we're going to talk about something new. Talk about finding maximums and minimums on a graph. I know graphs are everyone's favorites. That's why I decided to, make a video about it. Let's go over some key definitions here. We are going to talk about absolute maximum, absolute minimum, relative maximum, relative minimum. So when we're thinking about all these, I want you to think about a mountain range or a hill range, if you would. Mountain range. Now, I want you to think about the absolute maximum as the highest point of that mountain range. On a graph, the absolute maximum is the highest point of a graph. The absolute minimum is going to be the lowest point on a graph. The relative maximum, well, I want you to think about that as a peak. Here's why I want you to think about it as a peak, right? A peak would be something that looks like this. A relative maximum is anywhere the graph goes from changing directions from increasing to decreasing, right? It goes up and then it comes down. It goes up and then it comes down. So here I would have another peak, right? A peak of the mountain range. So these are kind of like peaks. And relative minimum, well, those are kind of like valleys, right? So those are anywhere where my function changes direction from decreasing. So it goes from decreasing to increasing. So we can think about that as a valley. So think of relative minimum as valley and relative maximum as peaks. And maxima is just plural, minima is just plural. So let's go into this example, see what we can do here. Let's start by finding the absolute maximum and absolute minimum. Sometimes those are the easiest to find for me. We have to find the highest point of this graph. Where do we think that is? All right, don't let your eyes be fooled. Check the ends first. Here's why. See how this arrow is pointing up? That means it's going where? I heard it from someone. Yes, someone said infinity. Someone said infinity. So this is going all the way up to infinity. Do we actually know what the numerical value of infinity is? We don't. So what we're going to say is that there is no absolute max here. It's going up to infinity, so it has no absolute max. What about an absolute min? Where's the lowest point of this graph? Well, be careful here because, again, we have another arrow, right down here on the right side of the graph. We also don't have an absolute min because we don't have a low point of the graph because it's going all the way down to negative infinity. If we don't know what the numerical value of positive infinity is, how are we going to know what negative infinity is? We'll move to relative maximum, relative minimum. Anywhere my graph goes from increasing to decreasing, increasing to decreasing, that point is my relative max, right? So we're looking for a little hill in the graph. So that hill is right here. I outlined it in red. So what I'm going to do is I'm actually going to see what this point is. So if we look, and I'm kind of just, estimating here on this one, it's not as clear. This is 1,8. The way we write relative maximum minimum, a lot of people just say it's y equals 8. However, what we're moving on to next, you're going to want to know the whole point. So let's just get into the habit of writing down the point. And we can just say it's at the point 1,8, but it's y equals 8. How about the relative minimum? Relative minimum, again, we want to think about it as a valley. Anywhere my graph goes from decreasing to increasing. So I've outlined it in blue. So that point right there, that's my relative minimum. So it's at the point -2, -4. And again, a lot of people just like to write it as y equals -4. So I'll write it both ways. So that's example 1. Let's move to example 2. This one's a little different here. So if we look at this, let's start with the absolute max. Where's the highest point on the graph? If you're seeing what I'm seeing, you're seeing 2 arrows. that means this thing's going up to infinity. It's going up forever. It's never stopping. So I don't have an absolute max. However, absolute minimum, do I have a low point? Are there any arrows pointing down? There's not. And this point right here, that's the lowest point of the graph. So my absolute minimum is just this point right here, which is negative 1.5, comma, negative 4. And now what I can do is I can find my relative max and relative min. So let's talk about relative max. Anywhere I go from increasing to decreasing, that's that point right there. That's 2, comma 0, or y equals 0. And then I have a relative min. Well, that's anywhere where my graph goes from decreasing to increasing, which is this point right here. So not only is this my absolute minimum, it's also my relative minimum. They can be both. They can share, right? Because it's the lowest point of the graph, but it's also a place on the graph where it goes from decreasing to increasing. So we get negative 1.5, negative 4, or y equals negative 4. Is that the only place, though? Is that the only place my graph goes from decreasing to increasing? It's not. I also have this point right here. So that point is negative 1, or sorry, not negative 1, 4, comma, negative 1. And that is also a relative minimum. So I can have more than one, right? So I get 4, comma, negative 1, or y equals negative 1. So those are a couple examples there of finding maximum, minimum, absolute, relative on a graph. So I hope that helps. If you have any questions, let me know.